review here. So if you're going back and looking at things, for the most part, most of it should be in order from the beginning of the chapter to where we stopped yesterday. There might be a few things that are out of order a little bit or something, but I know some of you have asked about like the directions and things like that. This is just something that shows up like with all of it, and it's not something that I can really get rid of. So really just pay attention to each problem, and each problem has like specific directions for the most part, what they want you to do. So on this one, we're asking increasing, decreasing, and constant. And so all you got to do is tell me the intervals for increasing, decreasing, and constant. Now this one's a little bit tricky because of the way it's drawn. I don't really like how it's drawn because it's a little bit deceiving. Because this graph is continuous from the left-hand side to the right-hand side. And so there is a line right here, and I colored it in with red so you can see it. That is the constant interval for this graph. And when we did it, typically it was like off the x-axis, but here because it's on top of the x-axis, we don't see it, or it blends in with the x-axis. But just realize that it is continuous from the left-hand side to the right-hand side, so you're going to write an interval for all of those. Also remember that you don't have to worry about brackets versus parentheses here. Everything can be a parenthesis because at each one of these points, like for instance at -3, it's neither increasing or decreasing. That's just where it's changing its interval. So however you want to do it, but like I like to label it first of all. This one's going down, this one's going up. This is my constant, and then this one's going down again. And so I have 2 decreasing intervals, 1 increasing and 1 constant. And we're just going to write those out. And remember that here's the other thing that probably gets missed the most on these is we're always going to go left to right. So we're only going to focus on the x values. We're not going to worry about the y values here. Okay? And that's probably the most common mistake. So I'm going to go all the way over to -5. That's where I'm going to begin. So at -5, we're going down until we get to -3. So we're decreasing from -5 to -3. And then at -3, we start to go up. So we're going to increase from -3 up to the origin, which is 0, 0. And then we're constant from 0 to 2. And then we're decreasing again from 2 to 5. So we're going all the way from -5 to +5 and identifying the interval that's going on in that case. What's that? Yeah, and that's, yeah, you don't have to worry about brackets here because the only time we really worry about brackets versus parentheses is when we do domain and range. When we do increasing, decreasing, constant, like for instance at -3 here. -3, there's 2 different values, and so we don't have to worry about brackets versus parentheses. So I'm not going to be looking for a bracket or anything like that because at -3 it's doing 2 different things. Okay, at 2 on number 2, that's just a graph. Once again, that one's a domain and range, so that one brackets and parentheses would make a difference. And that one's multiple choice, so that one should be a little bit more straightforward. Okay, on number 3, you're just looking for the relative min and the relative max. And remember, this is the one where they write it a little bit differently. You can find the ordered pair, like for instance, this would be the maximum. This one down here would be the minimum. And if, let's say, I did the maximum, it's okay for you to write the ordered pair of the maximum, which would be -2, 18. But the way that we write it is it has a max value of 18 at x equals -2. I always use the at symbol. They write the word at, so whatever, but at x equals -2. And then you would do the same for the minimum. Okay, and that one, once again, is multiple choice. Number 4 is the same thing, except they don't give you the graph, so you have to graph it yourself, and you can definitely use the graphing calculator for that. And then tell me where the minimum or maximum is. Okay. On number 3, you had both. You have a minimum and a maximum. But this is going to be an absolute value graph, so it's going to be a V. So it's going to be one or the other. Depends on if it opens up or down. This one's going to open up, so it would be a minimum. If you need to remember how to do that, then let me know. Okay, number 5 is that one where we talked about the dog pen or the dog run, and you're trying to expand or make the biggest pen you possibly can. You're going to write your answer in terms of one of the variables. So in here, you're going to write your area in terms of x. I won't go through the whole thing here with you, but I'll kind of help you to get it set up. I do think that it helps to kind of draw a picture out here. It tells me that the dog run is x feet long. And what we typically do then is we would say that the length might be y. They didn't tell me what, or the width would be y. And it doesn't tell me what the width would be. So I just can put whatever variable I want. If you want to use w for width, or I just use y because I had x, so x and y makes the most sense. Really doesn't matter. X is the only thing they tell me because we're going to write our answer in terms of x. So when you write your function, the only variable that'll be in there is x. They give me 2 things. When it talks about fencing, what does fencing represent? Perimeter, right? And so in this case, my perimeter would be 2x plus 2y. And we know the perimeter is 50 feet because I have 50 feet of fencing that I can use. So my goal here is I have to put y in terms of x. I already know what the length is. I have to put my length or my width in terms of x. So I need to solve this equation for y and put it in terms of x. So that's where I'm going to let you guys go from. Okay, solve for y, put it in terms of x, and then remember your area is length times width. So you can multiply those 2 dimensions together once you have y in terms of x. Okay. Questions on that one? But I told you that I'm not. Number 6, I don't like the way they write this one out. It's kind of hidden in here. F of 0 is what we're finding. Okay, it's kind of hidden down there in the problem. They give me, this is one of those piecewise functions where they give me 2 different functions. Remember, you're not going to use both of those functions. You're going to use one or the other, depending on what value I'm using to evaluate. If x is less than 2, I'm going to use this equation. If x is 2 or bigger, I'm going to use this equation. So if I was evaluating 0, like I am here, then which equation am I going to use? The top one, okay? If I was evaluating like 5, if it said f of 5, then I would use the bottom equation, okay? So it all depends on what value you're evaluating, to which equation you're going to use, but you will not use both. Okay, 7 is the one where we're going to graph the piecewise function. Okay, and I told you earlier that it's only going to be linear. Okay, I'm not going to give you like a quadratic equation or anything crazy here. So these are going to be 2 linear equations, but you have to graph it on the interval that's given. So you're not going to graph it over the entire graph like we would with most linear equations. Okay, you guys want to try that one, or you want to try to do it, or what do you guys think? You guys feel comfortable with that? What does, and I know this said f of x equals 3, which is the same as y equals 3. What does the line y equals 3 look like? It'd be horizontal, okay? It has a slope of 0, okay? So it would just be a horizontal line at 3 going through the y-axis. But we're only graphing it from 1 to the right. So we're going to go up 3, starting at 1. And that would be our first part, okay? Our first piece of the piecewise function. Okay, the second equation, and what I like to do here is I like to go ahead and put it in slope-intercept form, because that's what we're most familiar with seeing. Maybe it's a little bit easier to see it like that. I like to go ahead and just put the slope in here as -1 as well, or -1/1 if you want to write that. And what am I going to do when I graph this one? Where am I going to start at? -2, okay? So we're going to go down 2. Okay, and then from -2, my slope is -1/1. So we're going to go down 1, right 1, and here's where you got to be careful. It's going to be an open circle right there, because it's less than 1, not including 1. So it's got to be equal, or it's got to be an open circle. You can also go the other direction. You could go up 1, left 1. And I could keep doing that as many times as I want. And that would be your second piece. It's still a function because it still passes the vertical line test. At this part right here, that's why I need a closed circle and an open circle, because the closed circle makes it a function, and by the open circle being down here, there's only one point at 1. And so it does pass the vertical line test. Okay. Questions on that? So just graph and you can put it into your calculator, but you really can't like limit your domain on your calculator, and so that makes it a little bit harder. But you could look at like your x values and see where the graph would be if you wanted to do that. So you can use the calculator. It's just a little bit different application of graphing. Okay, then we're getting into our sum, difference, product, doing operations with functions. So they give me 2 functions. These are the ones that we did last week where we had like multiple parts to them. We had like, here's the 2 functions, do addition with it, do multiplication with it, whatever operation we have. Okay, this one here, we're going to do f plus g of 2. And remember, I told you there's 2 different ways that you can do it. You can add the 2 functions together and then plug in 2. Or you can plug 2 in to both of these individually, and then you could add them together. The order does not matter in that case. So either way you want to do that one would be fine. The one thing that I would warn you on number 9 is you're subtracting the 2 functions. Once again, you could plug in 3 and then subtract the 2 answers. If you choose to put the 2 functions together, then when you subtract the second function, you have to distribute that minus sign throughout. And then don't forget to plug 3 back in at the end. So you have a couple of different ways of doing those problems when you're plugging a number in. Number 10 is f times g. There's no symbol in between the f and g, so that's f times g. So that is going to be a FOIL problem because you're taking 2 binomials times each other. And that one you're not plugging a number in, so you're just going to leave your answer as an expression. 11, one of the other things that we did with this is when we did all the operations, we also determined what the domain was of all of these functions as well. So what x values are possible. So the first thing we have to do is we actually have to do the operation, whatever the operation is. And so I would encourage you to write that out first. This one says f divided by g. F is 2x minus 5. G is the square root of x plus 5. And so one of the things we talked about last week is when we do domain, what two things are we on the lookout for that restrict our domain? Radicals and what else? Yeah, radicals and fractions because of the denominator, right? We can't have 0 ever be on bottom of a fraction, okay? So fractions and radicals are the two things that we got to really be careful of here. So in this case here, the square root of x plus 5, I got to figure out what values. I can put whatever I want in up here, right? There's no restrictions for the top. There's no radicals, there's no, we can have 0 on top. So it's the bottom of the fraction, and we have both things that we're looking for here because we have a denominator and we have a radical. So what we're going to look for here, because we have a radical, and normally here, if this was not on bottom of a fraction, I would say x plus 5 has to be greater than or equal to 0, right? Because I can take the square root of anything that's 0 and above. I can't take the square root of a negative. But because it's on the denominator here, because it's on bottom, then I'm only going to say greater than. X plus 5 has to be greater than 0. And then we can solve for x. And we're saying x is greater than negative 5. And what I've been telling you for a while is this would be fine to write as domain, but your answer typically is going to be written, especially if it's multiple choice, in interval notation. So we have to decide which one of these is the same as interval notation for x greater than negative 5, and it would be D. So domain just kind of takes it a little bit further. You do the formula, and the formula hey, a real easy way to do number 12, you can add those two together if you want to, but adding them together really doesn't change anything. It would just be 3x minus 1 plus 3 over x plus 8, because it says the domain of f plus g. So if you wanted to write all that out, you can, but here would be the easiest way to do it, okay? What would be the domain of this function right here, 3x minus 1? Infinite, all reals, right? Because it's linear. It's a line that goes on forever in both directions, all real numbers. What would be the domain of the second one? You got to take out negative 8, okay? Anything except for negative 8. So when I put those two together, my domain is also going to be restricted at that same place. So this is the one domain that's taken negative 8 out of the domain. Because we have a denominator, x cannot equal negative 8. And so that's why D would be the best one. Okay, 13 was the one last week that we talked about that I told you from here on out, you just need to know that when it says difference quotient, they're really just asking the slope. It's another way of saying what is the slope of this function. And I told you I'm not going to give you any really crazy functions. It's probably just going to keep it to slope intercept, okay? So is it really easy to find the slope of that? Yeah, hopefully, right? It's in slope intercept form. Okay, you don't have to show the work and do all of that. You can just tell me what the slope is. Uh, 14 and 15 are the composition problems. Whenever I see this little circle, remember it's not multiplication. It's G follows F of 17. So I'm going to work backwards. I'm going to take 17, plug it into F, take that answer, plug it into G. So we're going backwards. 17 goes into F first, get the answer. Whatever you get there, you're going to take it, plug it into G. 15 is the same thing. except you're plugging it into G first and then to F second. Hey, 16 is kind of like what we talked about before. When I put one function into the other, what's the domain of 8x plus 72? Yeah, it's all reals, right? Because it's just a linear function, okay? All you have to do is focus on what type of function do we have. Same thing here, it's linear, right? So if I take a linear function and put it into another linear function, guess what I'm going to get? Linear function, right? So if I know I have a linear function, you don't actually have to do the work. If you want to, go for it, right? But just know if you have a linear and they're both all reals, then when I put them together, guess what my domain is going to be? All real numbers, okay? So just trying to say, don't make it harder than it has to be. Try to make it as easy as possible. Okay, and then this is what we've talked about this week. We talked about symmetry. We talked about symmetric to the x-axis, the y-axis, and the origin. This one is based off of a graph. We don't have a function. So what splits it down the middle? Does the x-axis, the y-axis, or the origin split it? You just have to look at the graph to determine that. And then is the difference quotient is, even if you did, the formula is provided there for you on number 13. So what's that? I think you have done perimeter enough that you can probably do perimeter. Because it'll just be a rectangle. And you just add up the four sides. So I think you got that one. Okay, I'll come around and help you guys if you need. On the last page, once again, we're looking at the graph. Here's what I want on number 19. Okay, I do want you to show me algebraically what that's going to look like. Okay, I know that I told you yesterday that you can do it graphically, and graphically would be a great way that you could check your answer, but I want you to show me the work for the x-axis, the y-axis, and the origin, just so we have some practice doing that. And that's why I left some extra space there, so you can write those out, okay? If all you say is x-axis, y-axis, origin on the quiz tomorrow, then you'll probably miss a half point, or I'll probably take some partial credit off, because I want you to show the work. So you have to show the work and then show me why. All right, on number 20, let's say that I plot the point 1.5, negative 1.75. I want to show you a real quick and easy way you could do this. Okay, I go to the right and I go down. That's where that point would be, right? All you got to do is plot that point, and we're not worried about being real specific about where it's going to be at. Just which quadrant is it going to be in is the most important thing, okay? If I say that it is symmetric with the y-axis, what that means is that's the axis that I am flipping it over. So if this is my point and I flip it over the y-axis, then it's going to end up over here, right? That's where my new point is going to be. And once I identify where that point is going to be, what do I know about all points that are over here in this quadrant? What's the sign going to be? Negative. Both negative, right? And so all I'm looking for is the one that has two negatives in it. There it is. Okay. Or you can also remember this. If it's symmetric with respect to the y-axis, then it's always the opposite of x. That's the other thing that we talked about. So you can either do it on a graph and plot it and then just flip it over the y-axis if you're a visual person and want to see it happening, or you could just say, all right, here's my ordered pair. I'm going to do the opposite of x, which is going to make this negative and keep the y negative, and that's going to put me there too. Okay, either one of those would be a good option. Okay, and then the last one, I'm not going to make you show the work on this one. I know we talked about doing this one algebraically as well. Just remember that if it's even, then it will be symmetric to the y-axis. And if it's odd, it'll be symmetric to the origin. And the easy way to remember that is odd is origin. Okay? O and O. And then even is symmetric. Okay. I know last chapter I gave you some formulas. I don't really think there's any formulas for this that need to be given to you. There's not. If there is formulas, I'll give them to you. But I don't think for this quiz we've really had any formulas. The only one that really needs a formula